Folks, look, we're going to add to our notes from yesterday. So let me show you just to make this as clear as possible. We're doing section 3 and 4 kind of together as far as notes go. Unless you don't have space, then you can put the notes on the next page. But it's really the same concept. We're trying to understand vocabulary and use that vocabulary as it pertains to graphs. So like minimums and maximums and relative max and mins. I don't really think you're going to find these concepts very difficult. It's just a matter of getting used to or familiar with the vocabulary, okay? So let's see if we can kind of extend that vocabulary a little bit. Well, we already know stuff about like x-intercepts and y-intercepts. And when I look down at this particular graph, right, the x and y-intercept is the same place. It's 0, 0. So to me, it looks like this thing has one x-intercept, one y-intercept, and that is at the origin. So, this is where it hits the x-axis, and the y-intercept's where it hits the y-axis, right? I mean, it's really that simple. Let's look at a different graph here for a second. If you saw this graph, it looks like the y-intercept is 2, or people often give the whole ordered pair 0, 2. And then there is no x-intercept, right? Because it looks like this is a horizontal line, so it's never coming down to hit this x-axis. So we know intercepts. You're probably like, don't waste my time, Nelson. I know about those. Linearity is a fancy word for, is it a straight line? Well, this is not a linear function. So the answer to this question would be no, it's not. It doesn't have linearity, but it does have continuity. So let's add some of that to our notes, and we'll make this real clear, because this sounds like a complicated word, and this sounds like a complicated word. This just means, is it a straight line? Okay, straight line. Sorry, my handwriting isn't neater. And then continuity means, could you graph it without lifting your pencil? Like, is it all connected? I'll put that word down. Maybe that makes sense. Is it all connected? And most of the graphs that you've seen are continuous graphs. It does have continuity. But the higher level math that you get into, you see stuff that does not have continuity. So these two both have continuity. So let's put that down here. They're both continuous. Another word, a conjugation of continuity is continuous, right? So hopefully I'm spelling that right. I'm missing a U, I think. Continuous. Boy, I hope I got that right. This means, is it connected, right? And so let's draw one does not have continuity. And sometimes you've seen this where there's an asymptote. I don't know if you remember that idea. But some functions look like this. And so this is discontinuous. Discontinuous. Okay? It is not connected. Like if you were going to graph this, you have to lift your pencil to get from here down to there and then start graphing again, right? So both these guys are continuous. And so this is a yes up here. This is a yes over here. You can graph them without lifting your pencil. And this is a no, not continuous. This is an example of discontinuous. All right, so I hope I made those vocabulary words clear. Positive just means, is the y value positive? Well, all these y values are positive because they're above the x-axis. So I'm going to put it like that. When you graph it above the x-axis, they're positive values, above x-axis. And then negative would be below x-axis, okay, below x-axis. I mean, it's really that simple. Like if I extend the y-axis down here, aren't these negative numbers down here? Like, it would be like negative 25, negative 50, negative 75. Oops, geez, negative 75. So these are negative numbers down here. These are positive numbers up here, right? Increasing means from left to right, is it going up? So I'll put it down like that, left to right. As you read the graph from left to right, going up. Okay, so this one right here, it's increasing up to here. We've kind of talked about this, I think, a little bit. So maybe add that to your notes. Let's see if I can write it in here at all neatly. Increase, or increasing. And then afterward, after that max, it's decreasing. That's what makes this a local max, right? So a relative maximum, that's what we used yesterday. Sometimes in calculus we call it a local max, but because it's in this local area, it's the maximum, right? And so over here it's decreasing. I didn't really want a capital D. Decreasing, right? And then it gets down to here, and then it starts increasing again, right? So this is increasing. It's really that simple. Is it going up or is it going down as you go from left to right? So left to right, it's going down. Left to right, it's going up, right? That's what increasing and decreasing. Add decreasing in here because it's, you know, the opposite of increasing. And then end behavior, we talked about yesterday. This is our end behavior, like, you know, that little arrow right there. This doesn't look like it's going to have end behavior. It looks like it stops right there. So end behavior is all about like these arrows at the end of your graph. And you can see that as this one goes to the right, as x goes to positive infinity, the y value looks like it's going up. So we'd say y is going to positive infinity. That's end behavior. End behavior, right? Let's compare that behavior. Let's compare that to this graph over here. Okay, so I'm going to move this graph over. Check out this end behavior over here. On the right, okay, as x goes to positive infinity, y looks like it's just flat out equal to 2. You know, when we talk about end behavior, I don't know if they'd put like equals 2 here or approaches 2. I mean, probably equals 2 is a better answer than approaches, because that's how you read this, y approaches 2. You would say y equals 2 probably because it's all 2 here. And as x goes to the left, you know, y equals 2, right? So as x goes to the left, y equals 2. Now let's try one of our homework problems. I believe this is question number 2, and you're going to have to match up what graph is correct for this information. Well, shoot, man, if they tell me an x and a y intercept, I'm definitely putting those on my graph first. It happens that there's only really one piece of information there, that the x and the y intercept are the same. Linearity, I'm not ready to draw a line yet, you know, like whoop, like this, because does it go this direction or does it go this direction? So let's look for a little bit more information. Well, it's continuous, means it doesn't really help me a whole lot. I'm just going to graph it without lifting my pencil. Here's the information I really need to know. When x is less than 0, see, that's these values over here. These are x less than 0, x less than 0. It's positive y values. Okay, so that means like this. Try to make it look straight because it says it's linear. And then when x is greater than 0, that's these numbers over here, the function is going this way. Now, if we check the end behavior, I'm going to skip all the way to the end. Look at this. Here, as x goes to positive infinity, that's the same as this right here. As x goes to positive infinity, is the y going to negative infinity? Look how the arrow's going down over here, right? You might say, no, it's kind of going to the right, but that means it's going down and it's going to the right. Both those things by that one arrow. So y is going to negative infinity. Hey, that matches up with this. That's what f of x means. F of x is just a fancy way of saying y, okay? That's the same thing. All right, and then what else do we need to know? Decreasing. Is it decreasing? Well, yeah, from left to right, it's all going down. Going down, right? So, yep, check mark, I took care of that. Continuous, yes, check mark. I didn't like skip. I didn't go like this. I didn't go, I'm graphing a line, then I'm going to skip some space, right? That's discontinuous if you do that, all right? Okay, so I hope I'm making this clear. I hope you can be successful with the homework. Thanks for watching my video and taking some notes.